All right, so I was going to do this video on creating a model from scratch for a new enclosure for the Circuit Playground kit that we did a project for making a light up beacon for Pokemon Go using the Circuit Playground. You can change the different team colors, and as the person walks, it starts flashing really bright white lights. This is just a laser cut enclosure, which is a little difficult to get put together unless you have access to a laser cutter and know how to actually weld acrylic together using acrylic cement. Most people are not going to be down for that, so I figured we would go ahead and try doing the 3D model so you can have a nice 3D model for your printer. So let me put that aside here. And essentially, I was going to show you guys how I can use my calipers and do all the measurements with the 3D program to get that all set up. But thankfully, Noah over at Adafruit was good enough to let me take a look at his 3D model that he's been putting together for Circuit Playground. So what I'm going to do is, this has got all the measurements that I need off of it. So I'm just going to take this, import it into Tinkercad, and kind of show you how I can make a basic holder for the Circuit Playground for the Pokemon Go badge. This will include a place for the battery to hold it. I have kind of this idea about trying to make it so that the battery actually holds the Circuit Playground into the enclosure, and we'll kind of see how that goes. So I'm just going to switch over here to Tinkercad, and I'm actually going to move my camera so we can see while I'm going through Tinkercad here. So for those of you who are unfamiliar with Tinkercad, basically what this is, it's a free program by Autodesk. It is an online program, and I've been using this to teach kids about 3D printing. It's really great because it's very easy. You can basically just stack a bunch of shapes together. You don't have to deal with the types of facing issues that I've had with doing 3D modeling in programs like SketchUp for 3D output. Yeah, I mean, we can put this enclosure together super quick, especially since we have a 3D model of the device itself. That would have been the most time-consuming part. So I'm going to go over here to import. I'm going to choose a file, and I'm going to upload that STL file. Let's see. Folder, Circuit Playground. I wonder why it's not showing up here. Let me double check where the file is. Downloads. Yeah, it should be in here. Circuit Playground. Okay, here it is. So I'm going to open that. Don't know if it's in inches or millimeters, but I'm going to go ahead and import it in millimeters and see how that is. That looks pretty right. So that should be 58 millimeters. Let me just confirm with the Circuit Playground. I seem to remember it was like 40 millimeters. Actually, no, 50 looks right. No, that was another device I was doing. I've been doing a lot of this type of using my calipers to measure devices, and do a couple of components for Eagle, as well as some enclosures for this stuff. All right, so yeah, 50.82 millimeters, and this is 50.78 millimeters. So yeah, that's pretty darn close. We do want to probably give it a little bit more room because the 3D printing does usually add a little bit to that inner diameter of something. So if we want this to fit inside of our enclosure, we're probably going to want to go out to, let's see, yeah, I might just push it out to like 51 just to be safe for the outer diameter of that. But let's go ahead and it looks like we do have a little bit of glitching in the import with some of those faces, but that's okay. This gives me the general idea of what the positioning looks like on that, and specifically like the height of all these components. So what I'm going to do is I'm going to start with a cylinder, and I'm actually going to make this a clear cylinder just so I can see. So I'm going to make that a hole first. I'm going to reduce the height of this, and this is basically going to be the outer shell of our piece. And I want this outer shell to just cover the top of that battery container, or the battery holder. So I'm going to go out Shift to increase this. The one gripe, I guess, about the about Tinkercad is that it doesn't allow you to just go in and enter in numbers for creating shapes. You pretty much have to just look at the numbers that are on there. But all in all, it's pretty good. So I'm going to align this stuff so that everything is centered. All right, that looks pretty good. And then I'm going to come here and look at the side of this. And just make sure that my enclosure is going to come just up above that. So let's see, 8 millimeter. Let's go ahead and lift that up. And let's see what the overall height, because it's the highest component. So yeah, 7, so that gives us about 0.9 millimeter, which I think should be enough for that. So we have our outer shell. That's cool. I'm going to duplicate this. And then what I want to do, this one is going to represent our inner shell. So first of all, I'm going to reduce the diameter of this to 51 millimeters. And then I also want to make the height that 7.1 millimeter. Actually, I might just go 7.25 millimeter. so that's a 7.25. Actually, you know what, I am going to go down a little more, and I'm going to do it 7.2. Yeah, this is my one complaint about Tinkercad. It's really hard to get like a precise number if you want those small numbers. So that's 0.1 millimeter over that battery enclosure there. There's a couple of windows here. And so this is basically our inner void that we're going to have. So now I'm just going to center all of those here to a line and center those. And then I'm also going to align the bottom of those. All right, so now I have these set as holes just so they're kind of transparent. But as you can see, I pretty much have like a disc that will have side walls and top walls. And that's the basic shape, excuse me, of what we want. So I'm going to change this outer one to a color. We're going to do orange just because it's nice and easy to see. Go down here, we can see the inner shell and that outer shell. And I'm going to group those so that it punches, excuse me, it punches that inner shell out of the outer shell. And if I drop this down, you can see I now have a nice little shell that this circuit playground should fit perfectly inside of. But I don't necessarily want to stop with that. So I'm going to switch this back over to the easier snapping method. I'm going to turn this back into a hole so I can see through it again. And now what I want to do, so basically this is my highest point here. So I do want to have that, I do want to have it flat up there, but as you can see, that wall is pretty thin. And I do want this kind of durable. This is going to be something people are going to run around. But if I put it to the side, you can see that really it's just this component right here, the battery holder, or the battery connector, that is the tallest component in there. And it doesn't go very far. And then there's all of this space here where basically it looks like the buzzer is pretty much the second tallest component in there, and it's right about in line with the buttons. So I can basically bring this down pretty much right over there. I probably won't. I'll probably make it so that it does have a little bit of room just because I want the LEDs to, this will also act as a diffuser for the LEDs. So I do want that to kind of shine through. But I need some of the top to get down close enough to those buttons so that I can make like an indentation in the top that allows you to press those buttons pretty easily from that flat surface. And I kind of have some ideas of how to do that. We'll kind of test them out and see. And then of course we need to do an opening for the USB. Or actually, I may not do an opening for the USB, just basically have it so that it accommodates, but it looks like it does kind of extend a little bit outside of the circle, so I might need to modify this part right here. One thing we definitely need to do is make an opening for the battery connector. So that's going to have to go outside. But I want this to look like as much like kind of a hockey puck type design just an indescript white disk as we can, so that it doesn't really stand out as being a piece of tech until the lights are turned on in there. So let's go ahead and we're going to add another piece to this disk. So I'm going to go in and edit this component. Oh, okay. All right, so all right, I'm going to select this. I'm going to duplicate this internal structure. And what I did was I basically just went into this grouping. Yeah, I'm going to go into this grouping to edit the holes and the solids. So I'm going to duplicate. Let's see how I want to do this. So actually, what might be the easiest way to do this is going to be to actually just reduce this disk all the way down. So I'm going to go to 6. That's going to leave me with, I think that should be enough to make this pretty secure. And it doesn't leave a huge amount of room over the button. So that looks pretty good for our circular hole. Now what we want to do, actually, it does look a little small. Just because I can kind of see the sides over there. So I'm just going to make it 0.1½. I'd rather give myself way more room for the piece than not. Alright. And actually, I'm going to re-center all of this stuff. Alright. So I'm going to go back into my grouping. So that's going to be the new shell. Now I'm going to go in and basically just create a box over that connector. That is going to be an additional hole to give me a bit of room. And I'm going to make that, so if I remember right, that was going to be 7.2 millimeters. So I'm going to go down, switch that to 0.1 millimeter increments, 1 and 2. Yeah, I'll just go 3. That's pretty good. I'll give myself quite a bit of leeway here. And then I'm going to reduce this down so it pretty much comes right up next to the sides of that piece. I do have a couple of smaller components that are around it, but they're pretty low, so I don't think I have to really worry about the sides there. Let's see. All right, so that's pretty good. I do want that block to extend out because I am going to be punching that out of the side wall as well. All right, so I think that does it for our basic shell. So now I'm going to select these two. I'm going to align them so that they're all on the base. All right, so now I have the inner shell. I'm going to punch that battery part out by grouping them. And now, yeah, as you can see, I got a nice little battery hole that comes out there, and you can kind of see. I'm going to actually make this a hole so you can see inside. So you can see inside that I've got quite a bit of room. Actually, I do want to get rid of that little pocket there because I don't really need it. So I'm gonna just bring this in enough to where it hits the back of that battery container. Because I will be having light coming through this. It is acting as a diffuser. And the thinner the material, the brighter that spot is going to be lit up by the LEDs. So I do want to have it pretty consistent going through here. Let's switch that back to a solid. And there we go. So now I pretty much have this set up so that little pocket in there just clears that battery connector. All right, so that's a basic design. If I wanted just to have no interaction, that would probably work with it. But I do want to have some interaction and be able to connect to those buttons. So I'm going to set this as a hole for now so that I can get some circles right over that button. So I want to make sure that whatever circles I'm going to have as like a push button are not going to get too close to that speaker there. I had that problem before with the design. And I wasn't able to actually push the button in there. So let's... Hey, Tony, I got a quick question for you. Tony? Yeah. So if on the 3D printer, what's like the thinnest shell that you would say I could probably print on there?
One surface, one
at
wall,
like, yeah, like,
yeah, or light setting.
what would the thickness of that be? Like, are we talking 0.1 millimeter? 0.4?
Just lay it down with layer.
Okay. So everything should be bigger at least than 0.4.
Should be, yes.
Okay. Then I'm probably pretty good at where I'm at now.
You want to test it out? I've loaded up the filament.
Yeah, we can test it out. I'm trying to see if I can do buttons so that there's like nothing, like it just looks like a flat surface, and if you press in a certain area, it'll like basically flex the center of the badge, and then have a knob basically on the inside that extends down. mean, we're talking like a flex of maybe point, or maybe 1 millimeter.
Yeah.
So like if we get like a 1 millimeter flex, we could try it out. Like, yeah.
If now we've got next question.
Can we,
Okay.
you got a camera mount for that tripod?
Camera mount for.
Can mount a phone camera. So Eric can mount his camera on the
Oh, the phone camera. We've got. I don't have one. We've got one that was. Well, they were using it for like 3D printing and a bunch of other stuff for filming it. But I thought Eric had used it last. Okay, so we're gonna try and. Sorry, I had to consult with our 3D printer expert here for a second, but so yeah, what I'd like to do is make it so basically like this surface is totally flat. Like you could look at that surface and you'd never know you'd never be able to see a button. But I do want to be able to push these buttons. So if I press on like this side, then it's going to push that button. If I press on this side, it's going to push that button. But also have it so you do have to push it fairly hard, because especially with this application, you're going to push it to change the color of whatever Pokemon team you're on, and you don't really change the color. You don't really change your Pokemon team. So I do want to make it kind of difficult for that to be pressed, and then I might as well do a button on this side as well, just for future projects. This isn't just going to be for Pokemon. Hopefully we can find a use for this case in other circumstances as well. So my plan is basically just have this top layer thin enough so that we can get a good flex out of it, and then just have a piece that's 3D printed that kind of comes down from the roof here and rests just on top of that button, so it doesn't take that much to press, because it doesn't really take a lot to register a click on these buttons. And of course, the beauty of 3D printing is that we can try this out, and if it doesn't work, we can make a tweak and see if we can get something else that's going to work. So let's see if I can get to, there we go. All right, so I'm trying to get to that button. We're going to raise it up. Yeah, so we can see there's a teeny tiny little gap there in between where the button is and where our knob is, and that knob is not really going to come too close to our buzzer there. I'm going to try and put it like about as in the center. Tinkercad, in some ways, is a pretty good program. You can get a certain amount of precision, but not like a huge amount of precision. So I'm just going to kind of take a bit of a guess at some of this stuff. All right, so I'm going to extend this up so that it just intersects with the roof of that. And now I've got like a little inner button on that button. I'm maybe going to decrease the surface area or the diameter of that, because we don't need it that big. We just need it to really be able to press that button. That should be more than enough. I'm going to again extend it so that it touches in here. This is what I love about Tinkercad, is that all I have to do is just intersect these shapes and it will fuse them all together. All right, there Oh shoot! Now I have to try and select that piece. There we go. And actually, just to make it easier to move this stuff around, I'm going to extend it so it's easier to select that one piece. All right, so I'm going to edit, duplicate. And then I'm going to move it straight across to the other button. And there we go. So I have my two button covers. I'm going to extend that down below the surface. And actually, that's pretty much it. Like, I think that is going to work. So let me change this back to a solid. And then what I'm going to do is pull that, I'm going to pull that down so we can take a look. So this is basically what the inner structure looks like. Really simple with those two little extensions that will hopefully let us push the button, our accommodation for the battery connector in there. Now there is one other thing that I want to do. Well, first of all, in order to make sure this thing is going to print, because that's a pretty wicked overhang in there, I'm going to group all these components together, and then I'm going to flip this 180 degrees, so I'll print it on its back. That is going to result in a much better print. And one other thing that I kind of wanted to do was, so basically this ledge represents the bottom of the circuit playground. Kind of had this idea, and I might just actually duplicate this. Yeah, I'm going to duplicate this piece, so in case it doesn't work out, we don't have to do too much. Save it. Put this off to the side here. And what I want to do is I'm going to take my battery. So I'm going to use this battery right here. This is a 1200 milliamp hour battery. It's pretty thin, not too big. And I'm going to measure the thickness of this. So the thickness of this battery is about 4.7 to, say, 4.75. Let's do 4.8. Let's see. Yeah, I think 4.8. 4.9, maybe 4.8. Still catches a little bit. You know, I'm going to go with 5. So 5 millimeters. That's what we're looking for. So I'm going to go into this group. I'm just going to start grouping. Stuff. And what I'm going to do is I'm going to extend that outer ring to let's see, so 5 millimeters, and then I probably want to have at least 1 millimeter on top of it. So it's going to be 6. So that's going to be around 15 millimeters that I want total. Alright, actually I'm going to switch to okay, so we're at 15 millimeters. And oh, you know what? Actually, we should have extended that other part first. Hold on, what happened? Okay, let's extend this part out in this direction. And then this one is going to go out to 15 millimeters. This is still going to punch a hole all the way through. And we'll just go a little bit beyond. All right, so that is perfect. Now what we want to do is we don't want that battery to be and we don't want this whole thing to be like that. We do want the battery to basically slide in here, and then it will hold down the circuit playground. So we're going to create a block that's going to represent our battery. We want that block to be 5 millimeters. And then we also want that block to be 8 millimeters from the top. And basically this is going to cut our slot. So if we can see, that pretty much comes right to the bottom of where the circuit playground is. And that looks like that's going to give us a perfect little slot to hold it in place. And actually, I might just keep the walls there because it will give it hopefully kind of a nice clean look to it, and make it easy to slide in and out. I'm going to measure the width of the battery, looking at 3,449. So maybe, yeah, I'll do 35 millimeters for the width here. So bring that out to 35. And this is kind of how I assembled the other one, just with like double stick tape and Velcro. So I know this is pretty much going to fit. I'll set that as a whole. And what I'm going to do now, I want to start centering this stuff, but some of it is not set up to be centered. So I'm going to group together the main case. Okay, so that's set. And now I can center things, and they should center properly. So I'm going to go to adjust, align. I'm going to center everything in this direction, align everything in this direction. Now we have it all set. going to group these two sides. And there we go. There is our enclosure. So we're going to try and 3D print that and see how it does, how it holds up. Hopefully what will happen is if I take my circuit playground here and flip this over, this is going to go down and sit nice and flush with this side here, and then so you pop the circuit playground down into the enclosure, and then you slide the battery in through this slot, and that holds everything in place. And then that way we don't have to attach like a pin or any of the magnet stuff for holding the button on to the circuit playground. At any time we can pull that circuit playground out and repurpose it for something else. We can instead put that on, put that magnet or pin on the battery itself, and that's what's going to hold it in. Ooh, of course, that brings up an interesting point. That's going to increase the size of the battery if we put that pin on there. So this would no longer work. So let's actually do one more thing here really quick. No, you know, I think I know of a way this is going to work anyways with that. So we're just going to go ahead and try and print this up. In order to do that, we're going to, I want to bring that outside there. I'm going to turn this. I'm going to bring that over to the side. So this is ready to go. I'm going to select it. And then I'm going to download for 3D printing. I'm going to download only the selected objects as an STL. And, oh, you know what, I'm actually going to name this first, because they do rename this stuff. So I'm going to name this. So, sir.
What is this?
Circuit.
I still
all right, share alike.
You know, like some of my this morning?
Oh no, I don't know. Might have been Bob. Another Christmas present.
Yeah.
No?
No. Magical Tool Fairy.
Jeremy. Yeah.
Maybe it's Jeremy Oscar.
All right, so that's it. We renamed the file. I'm gonna try and download that again so it's something that we can remember easily. Circuit playground. And actually I'm gonna wait to see how this turns out with print, make some tweaks, and then upload this up to Thingiverse, and I'll post in the comments what the link to that is, as well as share that with everyone at Adafruit. So hopefully we can get people printing some of those enclosures. All right, that's it, and thanks for watching, and I will see you guys later.